Okay. So my screen is visible to everyone. Yes, Sanjeev.
Sir,
Can you?
Yes, sir. Yes, visible to sir. Visible
Yeah.
to sir.
Okay. 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 So good evening, everyone. So today we have a third class, 28 May 2025, and still we are unit number one. That is an introduction to the electric vehicles. So in the previous class, we discussed the common components from IC vehicle to the EV drivetrain conversion, and then conversion to ICE vehicle to the EV. So part to be modified, and future there is a key challenges for the advancement. So these three topics we have discussed in the previous class. So is there any confusion, any query related to these three topics? So these three topics most important. So suppose you want to convert your ICE vehicle to the EV. So which type of components we have to change, and which type of components we have to modify, and which type of components we can use as it is. Correct? So these topics we discussed in the last class. So yes, students, any confusion from the previous class? Okay. If no confusion, then we can see uh, what topic we are going to discuss in the today's class. So starting with traction power. So how much power is required to move the vehicle and vehicle motion? Correct. So suppose you want to drive your vehicle maybe the 50 kilometer per hours. So how much traction power is required? Correct. Then type of EV. Also we will see. So how many types of EV available in the market? Duty cycle for the EV, and energy flow in the EV. So these four topics we are going to discuss in the today's class. Okay. So in the last class, I given the two assignments, say total three question. First question is what is a watt hour per kilogram and watt hour per liter for the petrol, coal, and wood? So we have to calculate. Suppose you have energy in the form of the petrol. Suppose you have energy in the form of the coal, and suppose you have energy in the form of the wood. Correct. So how much energy we will get in the form of watt hour per kilogram, and in the form of the watt hour per liter. So actually that we have to use in the vehicle. Correct. So I given this question in the last class. Three to four students already submitted the assignment, but I am expecting all the student you can try to solve this question, so you will get the more knowledge. Correct. So maybe the after one more class I will solve this numerical. So then we will see. So what is the correct answer? Correct. And second question, that is we have to calculate the energy ratio, energy efficiency. So comparison between the EV and ICE vehicle, and we have to calculate the battery weight and petrol weight per kilogram, kilometer, and then battery volume and petrol volume per kilometer. So this one is the second question. And third question, so you have to calculate the three force. So there is a aerodynamic force, aerodynamic drag force, rolling resistor force, and gradient resistor force. So we have a two velocity. First velocity is a 30 kilometer per hour, and second velocity, that is a 80 kilometer per hour. So we have a two velocity for the different vehicles. So we have a two-wheeler, three-wheeler, and four-wheeler. So suppose we have a two-wheeler, three-wheeler, and four-wheeler, and we have a two velocity. First velocity is 330 kilometer per hour, and second velocity, that is a 80 kilometer per hour. And weight also given. So there is a gross vehicle weight. So there is a total weight, including the driver weight also. Correct. So we can say, suppose 150 kilogram it is a two-wheeler weight and 50 kilogram for the driver weight. Then we can say overall total weight of the vehicle, and that is a nothing but gross weight, gross vehicle weight. Correct. That is a kilogram. CD is given, that is a drag coefficient is also given. Frontal area is given, that is a. Rolling coefficient is also given. Speed for the first vehicle, it is also given, there is a 30 kilometer per hour. Speed for the second vehicle, second velocity, that is 80 kilometer per hour, and tire radius is also given. So you have to calculate these three parameters, and all are the force, correct? So already 3 to 4 students submitted. So I hope maybe the next few days, you all will submit the assignment. Yes. So now we can start our original topic. So that is a power traction. So otherwise we can say the traction power and the vehicle motion. So this one is most important. So what is a traction power and the vehicle motion? So traction power is nothing but simple. To drive our vehicle, we need to give some power, correct? In the form of energy, we can say. We have to give some energy. So we have a motor instead of the engine. So we have to give the power to the motor. We have a motor, correct? So we have to give the input energy. So how much we have to give the input energy to drive our vehicle, correct? So maybe the motion is maybe the 10 kilometer per hour, maybe the 5 kilometer per hour. So how much we have to give the power? So there is a traction power. So source of traction power, we can say that for the ICE vehicle, so internal combustion engine vehicles, traction power is derived from the petrol or diesel engine. Yes, so for the ICE vehicle, input is a petrol, otherwise the diesel. So from the petrol and diesel, we can convert the power, correct? So that is based on the engine, which type of engines is there, then we can convert the power, correct? Second one, there is a EV. For the EV, traction power is supplied by the battery through the motor and the controller. Okay, so we have a battery, and that battery is connected to our motor and controllers. So why controllers? So because we have to control the speed and the torque. That is ultimately our goal, correct? So we have to control the torque and we have to control the speed. And we know torque is directly proportional to the current and speed is directly proportional to the voltage. So we have to control the voltage and current. So that's why it is required the voltage, and that's why it is required the controller. So we can control the speed as well as the voltage. So you can see we have to give the energy in the form of the maybe the petrol or diesel, maybe in the form of the electrical energy, correct? And then we can able to move the vehicle. So how much force? That is a traction force. So formula is traction force is nothing but, so this is the main formula. Yes. So traction force is nothing but first component. So that is like acceleration force. So we have to accelerate. So acceleration force, aerodynamic drag force. Third is a rolling resistor force, and fourth one it is a climbing force. So total 4 components we can combine, and then we can say whatever total force in the Newton into meter, that is your traction force. So acceleration force is nothing but mass into acceleration. Suppose mass is maybe the 50 kilogram, and acceleration is maybe the depend on the vehicle, so which type of acceleration you are giving, then we can calculate the acceleration of the force, acceleration force, correct? So these two formula is most important. So first formula and second formula. So please student remember, so traction force is combination of the 4 force. First one is a acceleration force, second one is aerodynamic drag force, and third one is a rolling resistor force, and fourth one is a climbing force. So this all force in the last class we already calculated. So what is the formula for this force? And for the acceleration force, that is a mass into the acceleration, correct? The energy consumed by the vehicle in the motion is integration of the traction power in watt second and it convert to the kilowatt hour by divided by the 3.6. How we will get the 3.6? Because we have to convert the hours to the second. So ultimately we have to convert the watt into second from the kilowatt hour, correct? So that's why there is a constant function is 3.6. So we can say in the 1 hour, so we have a 3600 second, correct? So ultimately we have to convert the unit, that is a second, to the hours, correct? Vehicle may have a regeneration. In the last class we discussed the regeneration concept. So many times we can use this term, that is a regeneration, which convert the deceleration of the vehicle by climbing down or otherwise applying the brake into the regenerative energy. So as I said in the last class, regenerative is nothing but, suppose you are coming from top to down, correct? And that time we are applying the brake. So while applying the brake, our motor is braking and it will work as a generator mode, correct? For motoring mode to the generator mode. And that generated energy we can store to our battery. So that is a regenerative braking system. Thus, the net energy consumed is R into energy, where R is a regeneration efficiency. So, how much energy we can recover from the regenerative braking, correct? That is the most important. So, regeneration factor is typical 15 to 30%. R is one regenerative factor, otherwise typically 0.85 to the 0.70%, correct? So we can say normally we can convert the regenerative energy 50 to 30% only. So you can see we have only 50 to 30% recover energy. Suppose we can recover the 100% energy, otherwise maybe the 90% energy, then you can say our vehicle is free of cost. So whatever energy we can give by battery, that energy we can again get back from the regenerative braking, correct? But that is not possible till now. But still research is going on, and people are trying to get the more energy from the regeneration braking. Okay, so most important, there is a 50 to 30%. So in the form of the regenerative energy, and other energy, that is a losses in the form of the heat losses, maybe the mechanical friction losses, maybe the electrical losses. So other energy, there is a losses. Okay. So traction power formula. So relationship between the traction power and the force. So traction power generate the force, that is a F traction, that propel the vehicle forward direction. Okay. So traction power is what? There is a traction force into the velocity. So there is a simple. Suppose you want to find out the power. So power is nothing but force into velocity, and here force is a traction force. So where V is the velocity, vehicle speed, meter per second. P, there is a traction power, there is a watt, and F traction, there is a traction force, that is a Newton. Correct? So that is your relationship between the power and the force. So simple, student, you can remember power is nothing but force into the velocity. Yeah, vehicle speed. Okay. Now torque at the wheel. So how much torque we can get from the wheel? Okay. Otherwise, how we can calculate the torque for the wheel? So traction power result in the torque, correct? So whatever power we can give to the motor, that ultimately that power converted into the torque, correct? At the wheel, which is responsible to the rotating them. So that's why we can rotate the wheel, correct? And that's why we can move forward direction as well as the reverse direction. So torque at the wheel is equal to force. There is a traction force into the radius of the wheel. What is a wheel radius? Maybe the 1 meter, maybe the 2 meter. How much radius of that wheel? Then we can calculate the torque. So torque is nothing but force into the radius. Okay, so torque is nothing but force into the radius. Radius of what? Radius of wheel. Okay, so that is your force. Okay. So still continue. So traction power applied to the vehicle motion. Vehicle required the traction power to move and accelerate In IC vehicle, this power comes from the petrol and diesel, but in the EV, we can get from the battery through the motors and the controller. So torque and rotational speed are the key parameter of the both motor. Yes. So that is maybe the both vehicle, there is a motor and engine, correct? So vehicle speed is related to the RPM. Normally we can use the vehicle speed in RPM. So we can say speed equal to RPM into 2 pi radius, there is a wheel radius divided by 60. So we can say 2 pi n by 60, correct? So this formula maybe you seen in the first year. So we can say this is the your omega. There is a radian per second, correct? So 2 pi n by 60. But here we can say speed is equal to RPM into 2 pi into radius, wheel of the radius divided by 60. So that is your torque, we can say. Okay. Yes, till now any confusion, any query? Yes, student. If you have any query, any confusion, then please let me know. Then we move ahead with the next topic. There is a type of electric vehicle. Is there any confusion, any query?
So the speed is the radian per second speed or meter per second in equation number 3.
So normally we have to convert kilometer per hours.
So,
Okay, so ultimately we have to convert kilometer per hours.
so the unit of that speed is in radian per second.
Yeah, here is radian per second. Yes. Okay. Any more confusion? Any more doubt? Okay. So next topic, there is a type of electric vehicles. So how many types of electric vehicles are available in the market? So normally we have a 4 type of electric vehicles. First one, there is a totally 100% operate battery electric vehicle. So we can say the battery operated electric vehicle. Second one, there is a IC engine plus battery operated vehicle. Then we can say the hybrid electric vehicle. So we can say ICE engine vehicle plus EV is equal to hybrid hybrid electric vehicle. Correct. So ICE engine, ICE vehicle, otherwise ICE engine plus EV is equal to hybrid electric vehicle. Third one, plug-in hybrid electric vehicle. Plug-in means you have to charge your vehicle. You have to charge your battery by plugging. In the case of the hybrid electric vehicle, no need to charge your battery. So by using the ICE engine, we can charge our battery. Correct? Then we can say it is a hybrid electric vehicle. But plug-in hybrid electric vehicle, you have to compulsory charge your battery by plug-in. So we have to connect the external source and then we have to charge our battery. Then we can say it is a plug-in hybrid electric vehicle. And last one, there is a fuel cell electric vehicle. It is nothing but hydrogen vehicle. Hydrogen vehicle. Is there any vehicle, hydrogen vehicle in the Nepal? Yes. Till now, any vehicle that is operated by hydrogen?
Is in the process doing in Kathmandu University.
So there is the research part,
Yes,
but not like actual running on the road, correct?
yes. I think the hydrogen car brought in Nepal, but for the research purpose, not in the commercial or other purposes.
Okay. But in the many country, like in India, already hydrogen vehicles is available and that is open for the people and that is a commercial use. And also for the well-developed country like Europe, Canada, Germany, they operated the hydrogen vehicle and that is especially for the like bus, for the passenger bus, correct? So technology is already developed, but still how we can control the hydrogen flow because hydrogen is a very dangerous. So how we can control the hydrogen flow, that is a main research task and how we can control, correct? So because hydrogen is a far dangerous compared to the petrol and diesel. Okay, so generally, so fuel cell electric vehicle we will discuss in the last unit. So energy storage management. So in the last unit we will see detailed structure of the fuel cell electric vehicle. Correct. So generally we can say we have a total 4 type of electric vehicle in the market. So first one is a 100% battery operated electric vehicle. Second one is a hybrid. So we can say the ICE plus EV. Third one, there is a plug-in hybrid electric vehicle. Here we have to use the external power supply to charge our battery. And last one, there is a fuel cell electric vehicle. So no need to use the battery, no need to use the petrol diesel. We can use the hydrogen instead of the battery, correct? Yes, still we have to use the small battery, but that is like external use for the like entertainment device, mobile charger, and etc. etc. But for the running of your vehicle, we can normally use the hydrogen. Yes. So battery electric vehicle. So slide number 16. So you can see figure 1 structure. So you can see the battery pack and electric motor. So by these two components, we can say it is a battery operated vehicle, correct? So battery operated vehicle is also known as a all electric vehicle. Okay. Also we can say the AEV, otherwise the BEV. Electric vehicle using the BEV technology run entirely on the battery power electric drivetrain. Correct. So totally operate by the battery. The electricity used to drive the vehicle is stored in the large battery pack. So we have to store the energy in the large battery pack, which can be charged by the plugging into the electricity grid. Yes, we have to charge this battery by plugging to our electricity grid. The charge the battery pack then provided the power to the one or the more electric motor to run the electric car. To find out the more about the battery electric motor, you can click the below link. So from this link, I got the information. So this is the officially Government of India website, e-Amrit. There is a niti.government.india. So you want to see the more information about the battery operated vehicles. So please click on this link and you will get the more information. Main components of the battery operated electric vehicle, there is an electric motor, inverter, battery, control module, and drivetrain. So these are the total 5 major components in the EV, that is a battery operated electric vehicle. Working principle: the power for the electric motor is converted from the DC battery to the AC. So that is a depend on the which type of motor you are using, maybe the induction motor, maybe the BLDC motor, yeah, which type of motor you are using, correct? So as per your requirement, you have to convert from AC to DC, okay? The controller adjusts the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. Again, so depend on the motor. So suppose you have an induction motor, so we can say by VFD controller, variable frequency drive, we can control the speed and torque. Suppose you have a BLDC and PMSA motor, then we cannot apply the VFD, correct? Variable frequency drive we cannot apply. So we have to go with a like different control algorithm, okay, to control the speed and torque. The motor then connected and lead to the tuning of the wheel through the cog. If the brake are pressed or the electric car is decelerating, the motor becomes the alternate and produce the power which is sent back to the battery. So that is nothing but regenerative braking. Okay. Example of the battery operated electric vehicle: MG ZS, Tata Nexon, Tata Tigor, Mahindra, Hyundai, Mahindra Verito. So lot of vehicles available in the battery operated vehicle. So here I given the like only few example for the various company. Okay. Yes. Is there any confusion for the battery operated electric vehicles? Okay. Next one, that is a hybrid. Same working principle, everything is same. Only one thing we have to add, and that is your fuel cell. Sorry, not fuel cell, fuel tank. So you can see here is a fuel tank we have to add. So suppose you are going to add the fuel tank, then obviously we have to add the engine. So these two components we have to add in the hybrid electric vehicle. Other components are same. So you can see the battery and electric motor, correct? So hybrid electric vehicle we can classify into three category. Series hybrid electric vehicle, so engine power generator and motor drives both are connected in the series. Parallel, so both engine and motor drive both are connected in the series, and series and parallel combination can operate in the both mode operation. So how we can classify this category? Because we have a two source. One is a fuel tank and another is a battery. So by both energy source, we can operate our motor. So maybe we can connect fuel tank and battery both are in the series. Then we can say series hybrid electric vehicle. And suppose fuel tank and battery both are connected in the parallel, then we can say it is a parallel hybrid electric vehicle. And suppose we can connected both series and parallel, then we can say it is a operate in the both mode, correct? But normally we can use the series and parallel hybrid electric vehicle. Okay. Working principle. So normally what we can do, the fuel tank supply the energy to the engine like the regular car. Battery run on the electric motor. Both engine and electric motor can turn the transmission at the same time. So normally what people can do, so in the starting condition, people use the ICE engine. So in the starting condition, normally we use the ICE engine. ICE engine. And during the, after the starting condition, we use battery electric vehicle. So because by during the starting we need the like more power, so we will get the more power through the engine. There is a ICE vehicle engine, correct? So that's why we can normally use ICE engine during the starting. Once the motor move like little bit distance cover, then we can convert into the battery operated vehicle. Main components, that is a engine, electric motor, battery pack with controller and inverter, fuel tank and control module. Example, Toyota, Prius, Honda Insight, Ford Fusion Hybrid. So various companies are designed the hybrid electric vehicles also. And nowadays in the market, so compared to the battery operated electric vehicle, hybrid electric vehicle is more demand because people are not depend on the totally battery operated vehicle. They are thinking like we have a backup with the IC engine. So that's why they are going with a battery operated as well as the ICE vehicle. So that is the same like the CNG. So I hope in the Nepal CNG vehicle also available. Is there CNG available? Yes, any one student. So CNG vehicle available. That is a compressed natural gas vehicle. Any student? Any idea about the CNG vehicle?
I think there is no cell CNG vehicles.
So
not
only petrol
in my
and
knowledge.
diesel vehicle.
In some
EV.
tempo, I think, sir, there is CNG. Gas is used, sir.
Okay. Because in India, majority like auto
So
driver.
CNG. So can we say CNG is like working on LPG gas?
Sorry. Can you repeat?
So small rickshaw and auto rickshaw work on that liquid petroleum gas.
Yes, LPG.
Yes,
Also, we can say
LPG,
LPG,
yes.
liquid petroleum gas. Yes, in India, majority auto and the passenger three-wheeler mostly operated by the CNG, and there is a hybrid CNG plus petrol. Correct. Even some four-wheeler also, some four-wheeler car also CNG plus petrol. Correct. So
So
that
we
is
can
a
say that CNG is like a liquid petroleum gas, or it is a different type of gas.
So it is a similar kind, but density is a different. So in the liquid petroleum gas density is different and CNG density is different. So we cannot say both are the same, but we can say it is both are the different, but there is a depend on the quality of the CNG and the liquid petroleum gas LPG. So how much there is like pure CNG, pure LPG, pure petrol, pure diesel. So that depend on the originality, then we can say it is both are same. Otherwise, both are not same. Little bit difference with the density. And while we can say the liquid fuel, then we have to see the density of the liquid fuel. So that's why in every petrol pump they are mentioning the petrol density, diesel density. Every time they are mentioning. Yes. So plug-in hybrid vehicle, there is a same. So here is we have to just use the external plug, correct, to charge our vehicle. Otherwise, that is the same like the hybrid electric vehicle. So plug-in hybrid electric vehicle can run in at least two mode. So all electric mode, we can operate the all electric mode as a battery operated electric vehicle. Otherwise, the hybrid mode. So there is a second application, correct, in which both the electricity and the petrol diesel are employed. So that is your plug-in hybrid electric vehicle. So hybrid and plug-in both are same. Only difference is in the plug-in hybrid electric vehicle, we have to connect the external power supply, correct, to charge our battery. So major components, there is electric motor, engine, inverter, battery, fuel tank, control module, and battery charger. If on-board modulet. On-board modulet means that battery charger is available on the vehicle. So while running, regenerative braking system apply and battery will charge, but there is a energy is only 15 to 30%. So ultimately we have to go with the external charger, correct? So we can say onboard charger and off-board chargers. We will see in the third unit. So there is like onboard charger, onboard charger, charging, and off-board charging. So this is the charging method. So we will see in the third unit mostly. So working principle again same. So starting time we can use like petrol or diesel, and then we can shift to the like battery operated electric vehicle. So many examples are there for the plug-in hybrid electric vehicle: BMW 330e, Chevy Volt, Mercedes, Kia Optima, Volvo. So many examples are there where they use the plug-in hybrid electric vehicle. Last one, there is a fuel cell electric vehicle. So instead of the petrol tank and diesel tank, here we have a hydrogen tank, battery, fuel cell, because hydrogen tank we have to convert into the electricity ultimately, correct? So instead of the engine, we have a fuel cell. So by this fuel cell, we can convert the hydrogen into the electric energy, correct? So that's why we have to use the fuel cell. PCU, that is a programmable control unit. So that is ultimately control unit, we can say, electric motor, and this is your wheel, okay? So in the fuel cell electric vehicle, additional component is a hydrogen tank and fuel cell. So why fuel cell? So we can convert the liquid energy into the electrical energy. That's why there is a fuel cell. Same like engine, okay? Electric motor, fuel cells tank, hydrogen storage tank, battery with converter and controller. Example: Toyota Mirai, Reval Simple Raza, Hyundai Nexo, Honda Clarity fuel cell. So many examples are there for the fuel cell. As I said in the beginning of this class, in India, many people have a hydrogen vehicle also, and even government is trying to move all the buses with the hydrogen vehicle, correct? For the small application, we cannot easily control the hydrogen flow. So that's why mostly hydrogen technology will success for the bigger application, maybe the bus or truck, correct? But not for the like car. So let's see. So maybe the high research and maybe the latest technology we can control the flow of the hydrogen. Then maybe we can use the like in the two-wheeler hydrogen as well as the three-wheeler hydrogen. Correct. Working principle. It is operated by converting the hydrogen gas into the electric through the electrochemical process. And electrochemical process is nothing but that is by the fuel cell. Okay. Unlike the battery electric vehicle that store the energy in the chemical form in the battery, and fuel cell electric vehicle generate the electricity on board as needed. Hydrogen storage. Hydrogen gas is stored in high pressure tank. Yes, that is we can store same like the LPG, yeah, CNG. There is a high pressure within the vehicle. These tanks are designed to save and resistant to the extremely condition. As I said in the beginning, hydrogen is too much dangerous. It is we can say like nuclear bomb, correct? So suppose it is a blast, so it will affect so too much area, correct? Maybe the like 100 meter, maybe the 200 meter, maybe the 500 meter, correct? So depend on the volume of the hydrogen. So it is a more dangerous. So we have to store in the safest tank. Okay. Fuel cell, yes, fuel cell. So what is the use of fuel cell? So hydrogen is fed into the anode side of the fuel cell. At the anode, hydrogen molecular are the spread into the proton. There is a hydrogen plus and electron. There is a electron minus using the platinum catalyst. So there is a basically application. Otherwise, we can say not application. We can say the operation principle of the fuel cell. The electron are directed through the external circuit, creating an electrical current that power the electric motor. Meanwhile, the proton travel to the proton exchange membrane. That is a PEM. So normally we can use the PEM fuel cell. There is a proton exchange membrane to cathode side. Okay. Oxygen tank. So why oxygen tank is required? So because we have a hydrogen atom and we have another atom. By combining of the hydrogen and oxygen, we can convert the electricity. So oxygen from the ambient of air. So oxygen is a free. We can take the oxygen from the air. Air is supplied to the cathode side of the fuel cell. Water formation. So what is the output? So here is no CO2. So here is output is only water drop. At the cathode, the electrode and proton oxygen combine from the water. There is H2O, which explained is the only emission. So there is no CO2. Only outlet is only few drop of the water. It is not like continue water flowing. It is not like that. Only few drop of the water. Power distribution. The electricity generated in the fuel cell is used drive the electric traction motor and charge the small buffer battery to use the auxiliary load. So we can also charge, otherwise we can also use the battery for the auxiliary load, maybe the mobile charger, maybe the LED, correct? And that we can get from the regenerative braking. Okay. So you can see the comparison of the different electric vehicles. So battery operated, hybrid, plug-in, and fuel cell. Primary energy source in the battery operated, there is a battery. In the hybrid, there is a combined. Plug-in, again there is a combined, but there is a we have to connect the charge. And in the fuel cell, there is a hydrogen. Charging method, there's a plug-in electric vehicle. No externally charger required in the hybrid electric vehicle. But in the plug-in hybrid electric vehicle, compulsory charger is required. And for the fuel cell, hydrogen refueling, it is the same like a petrol. Typically range, so 150 to 500 kilometer, there is a battery operated vehicle. Hybrid electric vehicle, there is a 500 to 900. Plug-in hybrid electric vehicle, there is a up to 500 kilometer. So there is a depend on the operation, maybe the like ICE operation, maybe the EV operation. And fuel cell, there is a 500 to 650 kilometer. Fueling time, server hours. So there is a maybe the fast time, fast charging, there is a 30 minutes, but otherwise it will take to 4 to 5 hours. Hybrid electric vehicle, few minutes because only gasoline. So you can see, you can go to the petrol pump and fill your fuel, correct? Same for the plug-in hybrid, it is a few minutes. And for the fuel cell, again, there is the same like the petrol and diesel. Tie pipeline emission, no emission in the battery operated vehicle. Hybrid electric vehicle low because here we can use the petrol and diesel. Plug-in again low, but in the fuel cell there is no emission. Maintenance need low maintenance, only few moving part, moderate, and low. Okay. Infrastructure required: charging station, gas station, charging plus gas, and hydrogen station. And these are the various example of the four type of electric vehicle. Yes, series, as I said, so we can connect the battery plus engine, both are connected in the series, then we can see it is a series operated motor, series operated vehicle. So advantage is simpler mechanism design, efficient to stop and go the traffic. So that's why we can use the series hybrid electric vehicle. Parallel, suitable for the highway driving, efficient energy use. Okay, so there is a parallel operation. Series and parallel offer the high efficiency and flexible in the different driving condition. But again, we have to control the both series and parallel. So controlling complexity is high in the case of the series and parallel. Yes. Any confusion, any query till now? So till now we discussed the power, that's the traction power, force, torque, speed, and type of the vehicle. So we discussed the four type of the vehicle. So any confusion, any query?
So in case of fuel cell,
Yes.
tailpipe emission must be water.
Yes.
But in the table it is said none. I think hydrogen and oxygen combines to form water.
Yeah, so there is an emission, correct? So water is not the emission, correct? So suppose output is a water, so water is not the emission, correct? So that's why here I written the known. So suppose you want so emission, so maybe you can write the water, but for my knowledge, water is not like emission. We cannot say water is emission. So that's why here I written the no pollution.
Yes.
Okay.
Sir, which one is more expensive and which one is cheaper, sir?
From your knowledge, which one is cheaper? So we already discussed the technical thing, correct? And we already discussed the like components. So as per your knowledge, maybe the instant your knowledge, so you can guess which one is a cheaper. Suppose maybe we can compare like four-wheeler, correct? So because in the case of the two-wheeler, hydrogen vehicle is not available. So we can compare the like four-wheeler, simple four-wheeler. So you can compare. So you can say which one is cheaper based on your knowledge.
Battery EV, sir.
Battery is cheaper या costly?
No, battery is the costly, but here there is a hybrid EV, plug-in hybrid EV, fuel cell EV, then BEV is cheaper, sir.
Okay. So yes. So suppose we can say the four-wheeler vehicle. So cheaper. So we can say the cheaper and same power rating, everything is same. Then we can say first number for the cheaper, that is your hybrid electric vehicle. Correct. So hybrid electric vehicle, that is the cheapest compared to the fourth. Then we can say the plug-in hybrid electric vehicle. Then third one, and then fourth one. So first one, there is a hybrid electric vehicle. Then second one is a plug-in hybrid electric vehicle. Third one, there is a battery electric vehicle. And fourth one, there is a fuel cell electric vehicle. So suppose we can consider the same parameter, same size and everything same. Correct? So suppose if any student want to add, otherwise justify, so maybe that first one is not the first one, maybe the second one is first one. Suppose you want to change the sequence, then please let me know. We can also discuss.
I think, sir, as per the range,
Mhm.
battery EV is cheaper. I think, sir.
EV is cheaper.
Yes, sir.
Battery BEV cheaper.
Yes, sir.
So this one is first number,
I think yes, sir.
and second number.
As in hybrid EV, both battery and gasoline is used. It
Uh-huh.
needs electric motor plus diesel engine or IC engine.
Mhm.
So I think it is expensive, sir.
So HEV, it should be the second number. Yeah, third number. So this one
I'm not
is
I'm not sure about HEV or PHEV, sir.
okay. But as per your knowledge, BEV is a cheaper car, correct? Compared to other three.
I think yes, sir.
Okay. So in the last class, we already discussed. So cost of the battery is too much. So suppose you use the single battery, correct?
Yes, sir.
Battery cost is too much high. Suppose you remove the battery from the battery operated electric vehicle, and then you can compare the ICE vehicle and the battery operated vehicle. Then we can say the battery operated vehicle is a more and more cheaper. Major cost is only battery. So that's why we can say the battery operated electric vehicle is a more and more costly compared to the other vehicle. And in this case, battery is the heart of the electric vehicle because everything is operated by the battery. But in the case of the hybrid electric vehicle, we have a ICE engine plus battery. So we can use the small size of battery compared to the big size. So that's why it is a less price. Yes, controlling is a very difficult part, but there is a not the aid the cost. So controlling is a what? There is only software part. So we have to write the control algorithm. It is a not aid the cost, correct? What should aid the cost that is like any physical parameter, any physical module like motor, like any in hydrogen tank, hydrogen protection tank, safety, cooling, there is a additional cost. Controlling, there is a not I think cost issue. Am I right?
Yes, sir.
So
So
maybe yes, maybe battery operated electric vehicle, as per your knowledge, maybe you can say cheaper, but technically there is a not cheaper because cost of the battery there is a too high. Maybe what we can do, maybe the I will compare technical parameter and practical application. So maybe I will take the technical data of the Tesla Model 3 and the Toyota, and then we will see. Okay, so maybe I will work out on this. What is the price of the Tesla Model 3, and there is a totally battery operated vehicle, and then I will take the price for the hybrid electric vehicle, and there is a Toyota Prius, correct? And then we will see. Okay, so
okay, sir.
cost wise, so there is like practical. So I will search on the Toyota website and take the price. Maybe you are correct, yeah, maybe I am correct, so but I am not sure. But as per the technical knowledge wise, so we can say battery is too much cost, and compared to the petrol and diesel, so battery is too much cost. Okay,
Okay, sir.
so in the next class I will show you the comparison about the actual cost of the vehicle, correct? Okay, yes, any other query, other confusion? Okay, now drive cycle for the electric vehicle. So what is a drive cycle? So drive cycle are standardized set speed versus time profile. So there is a standard waveform. So this is the maybe the time on the x-axis, and on the y-axis maybe the speed in the kilometer per hour. Correct? And time maybe there is a second. Correct? And we have to draw the drive cycle. Correct? Drive cycle means how we can check the status of our vehicle, correct? So we have to start our vehicle maybe just something like this, maybe size something like this, because we cannot continue. It is a not like steady state value, correct? Suppose somebody say it is a like linear line, it is a not linear line. We cannot always operate the vehicle is like steady state condition. It is not like that. So sometime maybe the acceleration, sometime maybe the de-acceleration, correct? So you can see sometime acceleration, de-acceleration, acceleration, de-acceleration, and then this type of drive cycle is there. Okay. So drive cycle is standardized set speed versus time profile used to simulate a real world driving condition in control and repeatable way. So how we can check our vehicle? Vehicle is good condition, yeah, no. What is the efficiency of vehicle? So while design of vehicle in the industry, they have to check the drive cycle, correct? The critical in the evolution vehicle performance metrics such as the energy consumption, emission, range, and efficiency. So many parameters we have to check, correct? So it is the same like you can say we are doing the MATLAB simulating current before going to the hardware. So why we are doing the MATLAB simulating? Because there is only software, and once we are satisfied with the software result, then we can move ahead with the hardware result, correct? So that is a simple example. But in the case of the vehicle, we have to see the performance also, energy consumption also, efficiency also, range also. So that's why every country decided there is a standardized drive cycle irrespective of the fuel. So maybe the fuel is a petrol, maybe the fuel is a hydrogen, maybe the fuel is a energy. Irrespective of the any fuel, there is a decided the standard cycle. For electric vehicle, drive cycle are used in the simulation to determine the battery use, regenerative braking effectiveness, and overall power performance. Okay, so that's why we can use the drive cycle. So drive cycle can be classified in the two category: modal driving cycle and transient driving cycle. So modal and transient driving cycle is very simple. So how we can say modal and driving cycle? So what is the meaning of modal driving cycle? The modal driving cycle comprises the constant speed and does not represent the real driving pattern of the vehicle. So we can say it is a constant speed. So we can say on the x-axis that is a time, and on the y-axis that is a speed. So that is a constant. So we can say we are drive our vehicle on the highway, and highway is like around like 50 kilometers distance, correct? So we can run our vehicle is constant speed, maybe the 90 kilometer per hours, correct? Maybe the 90 kilometer per hour. That is a constant speed. Maybe the for 1 hour, correct? So suppose maybe your highway is a 90 kilometers distance, correct? So you can continue drive your speed as a constant speed. Then we can say it is a modal driving cycle. This driving cycle, so this graph is not like continue increasing. So this graph is like constant. So something like that. So it is operate like constant speed, correct? This driving cycle will be used for the specific applications such as the emission test. So why we use this modal driving cycle? So we have to check the emission of the vehicle, how much emission. So there is a new European driving cycle, NEDC is an example of the modern driving cycle. Okay, so first cycle name there is a NEDC, and there is a new European driving cycle. Second one, there is a transient driving cycle. Of course, that is your, we can say the speed is vary with respect to time. Maybe the sometime maybe the 10 kilometer per hour, sometime maybe the 20, sometime maybe the 50 kilometer hours. The transient driving cycle represent an actual pattern of the vehicle which contain the acceleration, de-acceleration, constant speed, and everything. Correct. So that is your constant driving cycle. Okay. And we can say federal tax procedure, so there's a FTP 75 is the example of the transient driving cycle. So in simple language, we can say in the transient driving cycle is a practical driving cycle, and modal driving cycle there is a non-practical driving cycle. Okay. and that is a new European driving cycle, that is your modern driving cycle, and federal test procedure, that is your transient driving cycle. Yes, any confusion, any query? Okay. So what is the purpose of the driving cycle? The main purpose to assess the performance of the vehicle. There is a fuel economy, emission test, and etc. etc. Second one, to analyze the battery state and energy consumption. So we have to analyze the battery state. So there is a SOC, SOH in every parameter. To simulate the vehicle model prior to actual development. Simulate the realistic driving behavior in the laboratory setting and compare the performance of the different vehicle configurations. Suppose we have a Tata vehicle and we have a Mahindra vehicle, correct? So how we can compare? So maybe the comparison is cost, maybe the comparison of facility, correct? Maybe the comparison of mileage, but technical thing we can say comparison based on the driving cycle. Okay, so that's why driving cycle introduced in the market. Application of EV simulation. So EV driving cycle data is input to the vehicle model. So we will see, and you have to do the simulation in the MATLAB. So I will share the syllabus of the this subject, maybe the end of this day, yeah, maybe the tomorrow. So you have to use the drive cycle in the MATLAB Simulink model, and you have to check the performance of the vehicle. Used to calculate the battery SOC depletion, motor efficiency, regenerative braking, total energy consumption. So this type of parameter you have to check through the MATLAB Simulink model. Okay, so one of the total 9 experiment I designed. So maybe the second experiment you have to do this simulation, correct? Key parameters in the drive cycle. So there is a speed, kilometer per hour versus time, acceleration and deceleration rate, number of stop and ideal periods, average and peak periods, average and peak speed, and total cycle during the duration and the distance. So this type of parameters we can use in the drive cycles. So commonly used drive cycle, we can use the two types. So first one is a new European driving cycle, and second one is a federal test procedure. So there is a FTP 75. Okay, so normally we can use the two type of the driving cycles. So you have to use the federal test procedure in the MATLAB Simulink. So you can see the graph, correct? So new European driving cycle graph, you can see on the x-axis there is a time in the second, and on the y-axis there is a velocity. Otherwise we can set the speed, kilometer per hour. So you can see starting there is a steady state 0 speed, then increase, then again steady state, decreasing, again increasing, decreasing. So this is the real scenario in the city, and you can see this is the maximum speed. There is a 120 kilometer per hour. Maybe you can consider this is the highway. Okay, in the highway we can drive the vehicle very fast, correct? So total distance, that is a 11 kilometer. Okay, total time 1180 seconds. So we have to test, we have to drive our vehicle like 1180 seconds. Average speed, there is a 33.6 kilometer per hour, and peak speed there is a 120 kilometer per hour. So you can, suppose you want to see the more detail about this vehicle, this drive cycle. So just click on this link, so you will get the more information, correct? But this parameter is most important. So in the new European driving cycle, total distance is 11 kilometer. Total time there is 1180 seconds, and average speed there is a 33.6 kilometer per hour. Second one, there is a UDDS, there is a European dynamometer driving schedule. Otherwise, we can say the FTP 75. Okay, so this driving cycle I took from the MATLAB, and this same driving cycle you have to use in the MATLAB, correct? And this is the real driving cycle of the MATLAB Simulink, correct? Simulate the city driving with the frequent start and stop. So you can see in the normally in the city we have to stop vehicle, we have to drive because depend on the traffic area, correct? So that's why you can see the speed is a very less. So duration is a 1370 seconds and distance is only 12 kilometer. Okay, and you can see the maximum speed that is like around like 60 kilometer per hour. But in the previous case, that is like 120 kilometer per hour, just double. Okay, because that is like constant speed. We can say we can drive our vehicle on the highway. Okay. And this one is an Indian driving cycle. So maybe you can search on the internet for the Nepal driving cycle. So this one is an Indian driving cycle. So this is a IDC. Here is a graph of the Indian driving cycle for the two-wheeler, three-wheeler, showing the speed versus time over the 108 second. Correct. So this time period is most important. So you can see here is a 1370 second. Here is a 1180 seconds. But in the Indian driving cycle, there is only 108 seconds. Okay. The blue line indicate the speed variation. So this one is a speed variation. To accelerate and deaccelerate and study driving. So somewhere maybe the study timing. So you can see this is a study driving and then it's increasing. Okay. The cycle start and end as a 0 kilometer hours. So you can see the starting time and ending time, that is a 0 kilometer per hours. With the peak speed is a 42. Yes, peak speed is a, maybe this one is a 42 because this one is a 40. So this one is a 42. And variation is the transient in between. Okay. So maybe you can search on the internet for the like Nepal driving cycle. So maybe it is a similar to the Indian because India and Nepal both are the similar. So maybe the same driving cycle for Nepal also. Okay. But ultimately, main conclusion is driving cycle. So we have to check the performance of the vehicle. Okay. Yes. Energy flow, that is the last topic. But before going to start the energy flow, is there any confusion? Any confusion for the drive cycle? Okay.
Sir, how the drive cycle is decided? It is
Yes. Any confusion?
road conditions. Hello.
Okay. So energy flow in the electric vehicle. So how energy flow from the beginning to ending, correct? So I took this diagram from this paper. So analysis of the energy flow in the mid-size electric passenger vehicle in urban driving condition. So that publisher is a World Electric Vehicle Journal, 2023. There is a before 2 years paper. So I will share also this paper. So in the detailed analysis they are given. So very good paper. So I took this diagram from this paper also. Correct. So you can see starting from the left hand side, there is a battery. So this one is battery. Inverter plus motor. Reducer plus differentiation gear. So sometime maybe we can use the gear and sometime maybe we can not use the gear. So depend on the transmission system and depend on the vehicle configuration. And here is a vehicle inertia. So total 4 components. The first one is a battery, inverter plus motor, third one is a gear system, and fourth one is a overall your vehicle power. Correct. So I can change the color. Yes. No. Light blue. Okay. So you can see the when we can use the battery. So battery, suppose battery input voltage is 48 volt, correct? And output may be the not exact 48 volt because there is a losses. So this is the EB losses, battery losses. EB output. So suppose input is a 48 volt and we consider there is like 95% efficiency. So there is a battery output. Then DC to DC converter. So again, there is a depend on the type of motor. So we have to use the converter. So we can say the DC to DC energy, and that is the input of the converter energy. And then inverter and motor. So we can say the EM out and converter in. Otherwise, we can say the EM out, there is a motor output power, and there is a inverter input. Motor output power is equal to the reducer or differentiation gear input power. Correct. And ED out, that is a differential energy out is equal to the vehicle velocity, otherwise vehicle energy, correct? So you can see the losses. There is a motor and inverter losses, battery losses, gear losses, and EWI and ERL. That is your friction losses, correct? So energy transfer driving. So there is a green line. There is a energy transfer driving. Energy transfer for the regenerative. So this line there is a regenerative energy, and red color there is a energy losses. Okay. So this one is a losses. This one is a brake pad losses, gear losses, motor inverter losses, and braking energy losses. So these are the losses. Okay, so here I mentioned the energy transfer of the driving. Blue arrow, there is energy transfer for the regenerative. Red arrow, there is energy losses. Okay, so there is a simple concept. No need to memorize this diagram. Just think about, we have a battery and we have to run the vehicle, correct? So for the battery, there is an input energy. We can connect the battery with our motor and inverter. Then motor and inverter, there is a connected with the transmission line. Otherwise, we can say the gear system, and then it is connected to our wheel. So we cannot use the 100% energy. So maybe the 98%, maybe the 90%. So ultimately, whatever losses are there, we have to consider the losses, and then we can transfer the output energy, correct? Yes. So this one is a just explanation. So what is the output and input? So battery, so EB out, there is energy output from the battery. EB loss, there is energy losses of the battery. DC-DC converter, E capital I in, energy input to the inverter. DC-DC losses in the converter. EM out equal to ED in, there is output from the inverter. EMI losses, there is a losses in the inverter. Motor output, there's a ED output of the drivetrain, and E gear losses, there is a gearbox losses. Okay. Yes. Any confusion, any query? So I will share this paper to you. So you will see how we can calculate all losses and everything. Okay. So is there any confusion? Any doubts from the today's class?
Sir, one
Yes.
more question.
Yes.
Sir, motor plus DC inverter. So, in case of BLDC motor, there is a need of AC power. If not, then why is inverter is there, sir?
So this is a common diagram. So this is a common block diagram. Even again, so here DC-DC converter is not required. Suppose here I can use the induction motor, correct?
Yeah.
So then DC-DC converter is not required. So we have to use the DC to AC.
Inverter.
Yes, correct. So this is a generalized diagram. So depend on the configuration, depend on the which type of motor you are using. So normally we are using the induction motor, BLDC motor, and PMSA motor. Correct. So depend on the motor, you can modify this diagram. But this one is a generalized diagram, so we can refer. Okay. Yes. Any more question?
Sir,
Okay.
hello.
Yes.
Sir, how this drive cycle is decided?
Yeah. Good question. So this drive cycle is normally tested more than 60 times for the same operating condition. Okay. So in the previous time, when we don't have a technology, so that time we have a track, there is a physical track. So suppose you want to make your license, correct? So we have to go to the RTO and we have to drive the vehicle, correct? So in the India, we have a number 8. We have a number 8. So we have to drive on the number 8. Suppose you are failed to drive in the number 8, so you will not get the license. Maybe in the same thing is available in the Nepal, correct? So
Same,
once
sir.
the,
Yes, sir. Yes.
yeah, same thing available, correct, in the Nepal also. So
Yes, sir.
yeah, so suppose you are passed in the drive in the number 8, then you will get the license. So in the same case for the driving cycle, They are testing the in the previous time. So while we don't have a technology, so in the previous time, they have a track, so physical track. So they have a something like this type of track, and they have to drive the vehicle in this track within the time limit. So see here, time limit is a 108 second, correct? So within the time limit, they have to drive the vehicle in this track, and based on this drive, they have a various sensors. Here is sensors available. So they record the data, and then based on the multiple analysis, they decided now we have to finalize this drive cycle for the every vehicle. So based on this data, they can finalize the drive cycle. But now we have a more technology, so no need to use this track. We have a sensor. So what company will do? So while design the vehicle, inside the company they have a test bench. So we can say the test bench. They have a test bench. So what they can do? So they have put the like vehicle load. Suppose vehicle load is maybe the 500 kilogram. So they can put the 500 kilogram weight on the wheel, and then they will run the wheel at the particular different speed, and then they will decide now my vehicle is a very good condition, and then based on this vehicle condition they have to decide the driving cycle. Got it?
Yes, yes.
Yeah. Any more confusion? Any more query? So this drive cycle is standards, and so normally we follow the like some standard ISO standard, IEEE standard. So suppose you want to design the any vehicle, two-wheeler, three-wheeler, or four-wheeler, irrespective of the EV or ICE, correct? So you have to follow the drive cycle first. Then you can design your vehicle, correct? So maybe some student maybe send me the drive cycle for the Nepal driving cycle, correct? So this is the Indian. So I am sure for the Nepali also available the drive cycle. Okay, so maybe somebody send me the image for the drive cycle. Okay. Yeah. So key points from the today's class. So we discussed the traction, power, and the vehicle motion, type of the electric vehicle and drive cycle, and as well as the energy flow in the EV. So in the next class, we will be discussing on calculate the mechanical power with and without gear. Suppose we have a gear, then how we can calculate the mechanical power? Ultimately, we have to produce the mechanical power, correct? And suppose we have a gear, then how much power and how we can calculate? Then in grid. So we can say, suppose you want to charge your vehicle, so we have to use the we charge our vehicle through, then it will produce the harmonic, sway, and everything. So what is the actually effect on the utility grid, and what are the benefits? And then we will discuss the numerical of the EV. So maybe the next class is the last class for the first unit. So I will try to complete the first unit in the next class if possible. Otherwise, I will take 30 minutes more in the next class, and I will complete the first unit. Then we will start the second unit. Okay. So meanwhile, I already given the assignment. So please complete the assignment, and do not copy paste from the other student. If you copy paste, then ultimately lost it is for you. So try to understand, and ultimately during the numerical session, I will cover the same example. But before that, it is my humble request to submit your assignment. Okay. So these are the few references. I already shared this NPTEL video lecture for the Professor Ashok Junjunwala. So I also refer this video lecture to prepare the lecture notes. So you can also refer. And this one is a research paper. I will share this research paper maybe the end of today, otherwise maybe the tomorrow. Okay. So thank you so much for your attention. Yes. So thank you so much. If you don't have any queries, then we can stop the today's class. Any query? Okay, then thank you so much. We will meet on the next class.
Okay, thank you, sir.
So thank you, sir.
Thank you so much.
Thank you so much, sir. Thank you, sir. Thank you.
Thank you.